Okay,
Okay,
Cristina
thank you.
Fernandez is from Iris, from a Spanish company located in Barcelona, and she will be talk about, it's a PhD in food science from the University Autonomous of Barcelona and the University of Guelph in Ontario, Canada. Dr. Fernandez is a food scientist and nutritionist with expertise in food emulsions, and she has been working in emerging non-thermal and thermal technologies scalable to the food and nutraceuticals industry. Your presentation, Cristina, will be about the AgriMax project and entitled Agri and Food Waste Valorization Co-ops based on flexible multi-feedstocks biorefinery processing technologies for new high added value applications. So, Cristina, please go on.
Okay, thank you for the presentation. Do you see the screen in presentation mode?
Yeah, it's okay.
Okay, perfect. So AgriMax, a project that has been, it has been a duration of 5 years. Actually, recently, yesterday, you received some good news. And most of the partners that joined the European project are attending this webinar today. It's a project about, as you were saying, about revalorization of byproducts of the agriculture industry. So basically, apart from having the products, we also have byproducts. So what do we do with them? Because we have residues, then the vision of AgriMax is not just produce new chemicals and packaging and food products from the different sector. Also use the byproducts to produce new products, and also use the byproducts for the development of energy by biorefineries. Another thing is that we can also use the biofertilizers that I derived from the project into the agriculture, and then we close the loop, as you can see in this image. What are the objectives of the project? So we wanted to demonstrate the technical and economic feasibility of multi-feedstock biorefineries in order to valorize the waste. And then we could increase the sustainability along Europe's agriculture and food sectors. So we created new bio-based food products, products for the food, packaging, and agricultural sector. As you can see here, this is the whole picture of how the consortium look like. So the different partners, and the different raw materials. So basically, according to that calendar, we could fill the calendar. So basically, the tomatoes, the wheat, the potatoes, if there is byproducts along all the year, then we can use them, right? So basically, the two pilot biorefineries were designed for that objectives. They were newly built in Italy and Spain. And the objectives is to use environmentally friendly biopackaging as well as bio-based agricultural products. It is a technology solution, so our role in the project, we act as coordinators, and the focus of the company is to have we have different photonic tools. We do the real-time monitoring in different industries. And then along with digital platforms, we can control this, and also we have algorithms that we can control, we can use for the real-time monitoring of the process and optimize the processes. Also, we are involved in other European projects. And basically, I wanted to show you the valorization of the products in AgriMax regarding the packaging. Even also there were other kind of valorization regarding food products and fertilizers, as well I was explaining before. But basically, I'm going to show the packaging outputs, which actually most of you develop, and you are here today. I'm not an expert regarding this, but this basically is the wheat valorization strategy that was taken for the wheat cereal, and you could obtain flour and bran byproduct. And from that, you could obtain mycelium-based materials for bio-based secondary packaging. This was developed by Mogu. And then also another kind of extraction strategy is the phenolic acid, which was developed by these partners, and they could use the additives for bioplastics or the monomers for biopolymers. In the case of the mycelium, you can see in the image in the middle that it is acting as a binding agent for the substrate, and it does provide the strength to the new bio-based material here. And it's interesting because you can improve you can make packaging like you see on the right side of the slide, and also, well, here you can see the contact details of the person in charge in each slide, so feel free to contact them for more information. Well, this picture on the right that I was seeing is it was a luxury packaging for farming materials. And why this is having an impact regarding environmental sector? Then this product is fully biodegradable, and it uses low energy, so we use less consumption. And also the microorganisms are not they are harmless to humans, and also they use non-GMO, non-allergenic fungal strains, and we are contributing to the green economy. What else? There's also the phenolic acid, which is actually having a chemical structure. The molecule is chemically similar to PET, and then it's bio-based. It has no competition with food. It may confer additional properties to the material, like antioxidant properties, and it's harmless. Also, it's the best candidate to substitute the PET, because it's conferring high barrier properties. So if you want to contact University of Bologna, feel free. Then we do have the microfibrillated cellulose fibers, the MFC. This was developed by Yetene from agricultural wastes, in this case potato, oat, and spelt. And it provided high barrier flexible packaging. And also, well, this regarding the coatings, and also the other application was the rigid food packaging. And why this is innovative? Because we achieve similar properties to commercial MFC, which is conventionally obtained from wood pulp. Then why this is environmental, societal, and the economic impacts? Well, actually, MFC and the ferulic acid are replacing the petrol-based polymers, and this bioactive packaging, it's reducing the gas greenhouse emissions. So it also has no competition with the food production. And it's interesting because it could be exploited to make other formulations and other blends with biopolymers, and it's kind of opening the new market for other opportunities for the end users as well as farmers and primary producers. Here we can see these nice cookie packaging pods developed by University of Pisa, and you can see different biocolors, and it was produced with 15% of bran. So this could be used as packaging of cookies and other things. And here you can see the products of cutin. So basically, Serena will explain better later in the next talk. And this was extracted from the peels and the seeds of the tomato. Well, I'm going to the platform that we developed in the context of the project. So basically, AgriMax is a marketplace in which you can sell and you can buy products. So here you see a dashboard, how it would look like if you were a user of this platform. So you would have here the synergies that you have with other partners, or clients in this case, the total number of resources that, for example, you can offer, and the completed synergies, so the status of everything, if there is a contract that is ongoing, it's requested, and you can see the rest of the synergies from other companies, and here on the right side, the news, the update, and on the left side, the summary of the dashboard that I was saying. Here, for example, specifically on the resource details, you could see if you are, as an example, offering potatoes. So from when are you offering until when, how many kilograms? So this is basically closing the loop of what I was saying before. If the production of tomatoes, it's all year round or not. So this is kind of closing that gap and offering byproducts all year round. So you can see here in your synergies if you have requested, or you are 26 kilograms, if it's already signed, if it's requested or completed. And it's very interesting because you can have it, you can have the summary of everything that you have taken and you want to take. Okay, so that is all.
Okay, thank you very much, Cristina. We have time for 1 or 2 questions. The floor is open. Okay, Ipsita, and then Mari Carmen.
Thank you for that nice talk. My question was about the MFC that you were discussing. What sort of substrates and organisms are you using for the MFC production? And what scale again? The microfibrillated cellulose that you produce?
Yes. Okay. So So what is the, can you repeat it, please?
Yeah, sure. What is the organism and what substrates? Are you using glucose, or what is your substrate for the production? And what scale, what volume are you using for the production?
The substrate is wheat bran. And the microorganisms, well, it is the mycelium that is acting as a binding agent. I'm not so sure about the volume because, well, but you can contact the university, so Annalisa, and then she can give you more details. I can pass you the contact if you're interested.
Sure. Okay. Thank you so much.
You're welcome.
Now, another question from Mari Carmen.
Thank you, Cristina, for this interesting presentation about the AgriMax project. My name is Mari Carmen Garregós from the University of Alicante. I would like to ask you about the ferulic acid extraction. I don't know if you can give some details about the technique which was used or other information, or maybe this is a question for the University of Bologna, I don't know.
So,
what is the question about ferulic acid? My colleague developed the polymers based on ferulic acid.
So, sorry, I think I can answer both questions as I've been the technical manager of the AgriMax project.
Thank you, Andreas.
So regarding the cellulose, it was not a fermentation, it was a mechanical production process, and it was scaled up during AgriMax, I think, finally to a scale of around 50 liters volume. And the ferulic acid process was an alkaline extraction followed by a purification by adsorption.
Oh, I'm very sorry. So the source of your cellulose was bran. You extracted it from that. Andreas? Okay.
Please consider our folks that are watching on streaming, don't listen to you if you don't use a microphone.
If I remember correctly, yes, there was an alkaline treatment as well, and then a fibrillation by a grinding process.
Thank you.
Okay, we have time for a very last question from Fran.
Thank you, Francisco from KTA. It's a very quick one. I guess the source for the ferulic acid was also bran. Then my question is, the content is very small in the bran. So how, let's say, in terms of mass balance, if you're taking like a 1% ferulic acid, I mean, the productivity for the plastic industry must be very low.
Exactly. That was an issue in the project that finally turned out that the ferulic acid process was not really economically viable.
Yeah, thank you.
So thank you, Christina, and all of you who are participating in this very animated and very instructive discussion that I be sure that it will be continued during lunchtime, but sorry, but we have to move forward. So thank you again, Christina, for your presentation.
Thank you.